Since the first time humanity gazed up at the starry night sky, the universe has remained a place of mystery, allure, and challenge. Distant stars, mysterious planets, and the infinite void beyond have always stirred a fundamental question. Who are we? Where do we belong in this vast and enigmatic canvas? These mysteries ignited a burning desire in the human heart, a yearning to surpass all limits and seek answers in the boundless universe. It is the greatest adventure ever undertaken, and also the most daunting in our history. Against all odds, humanity began its journey into space with the smallest of steps, building toward monumental leaps. We chose to confront our own limitations, proving our perseverance, courage, and an unending dream. To this day, that journey has not ceased. So when did we first ignite this daring mission? Beyond braving challenges, what milestones have we achieved? Let's look back on humanity's glorious journey in today's video. From Earth to the stars. Humanity's journey into space began long ago. From the earliest civilizations, people developed unique ways to explore and understand the cosmos. At a time when tools were still rudimentary and telescopes did not exist, all astronomical knowledge came purely from observations with the naked eye. Back then, people closely monitored the movements of celestial bodies such as the sun, moon, and stars. From these observations, the earliest cosmic patterns emerged, including the cycle of day and night, the changing of seasons, and the phases of the moon. Civilizations like Egypt, Mesopotamia, India, and China were among the first to observe and record astronomical events. They developed calendars, determined planting seasons, and aligned their daily lives with the stars. Events such as solar and lunar eclipses were carefully documented, reflecting humanity's limitless curiosity about the universe. To acquire that early understanding, ancient people had to spend generations watching the sky and recording the movements of celestial bodies. Among the most prominent were the achievements of the ancient Babylonian astronomers, dating back 4,000 years. They possessed a remarkable knowledge of the cosmos and were even capable of predicting natural events. In addition to observing, they used simple tools like altitude measuring sticks, circular markers, and wooden boards to determine the positions of celestial objects. They could identify constellations and, from there, created myths and stories about the stars they saw. This classification of constellations helped not only with navigation, but also in predicting weather patterns and agricultural cycles. Most notably, the astronomical knowledge gathered solely through naked-eye observation laid the foundation for one of humanity's most significant scientific systems, the cosmological model of ancient Greek civilization. It was distilled, formed, and developed by philosophers and astronomers, serving as the foundation for future human understanding. In the 4th century BCE, scholars like Eudoxus proposed the idea that the stars were fixed on a celestial sphere and revolved around the Earth once every 24 hours. Meanwhile, the planets such as the Sun and Moon moved within the space between Earth and the fixed stars. This model continued to evolve in the centuries that followed, reaching its peak in the 2nd century with Ptolemy's comprehensive system. He believed that perfect motion must be circular, so he argued that planets and stars revolved around Earth in perfect circles. However, to explain the complex and cyclical movements of the planets, Ptolemy introduced the concept of epicycles, smaller circular orbits that each planet followed while still revolving around Earth. This became known as the geocentric model. The geocentric theory originated in the 4th century BCE, proposed by the philosopher Aristotle, asserting that Earth was at the center and motionless. Nevertheless, some philosophers also introduced the heliocentric model, in which the sun was considered the center of the universe. However, this viewpoint was not widely accepted in ancient times. This is because, when observing with the naked eye, we only see the sun, moon, and stars revolving around the earth. The cosmological model of ancient Greece truly reflected the development of human thought regarding the universe and our place within it. Although limited, their theories and discoveries laid the foundation for future knowledge in astronomy and science. The combination of observation, knowledge, and belief created a valuable legacy, allowing humans to continue exploring and understanding the vast cosmos. Moreover, based on astronomical knowledge, humanity invented calendars as early as ancient times. They realized that the cycles of the sun, moon, and stars were repetitive, leading to the division of time into units like days, months, and years. A day was defined by the Earth's rotation on its axis, from sunrise to sunset. A month was often based on the moon's cycle, typically the time between two full moons, around 29.5 days. And a year was defined by the time it took Earth to orbit the sun, approximately 365 days. Each civilization had its own calendar and method of timekeeping, but the most famous are the calendars of the Maya and the Babylonians. First, the ancient Mayan calendar is one of the most complex and accurate calendar systems in history, developed by the ancient Maya civilization in Central America. It includes three main types: the Hab calendar, the Tzolk'in calendar, and the long count. Each calendar had its own purpose and counting method, but all were interconnected in the Maya's timekeeping system. However, these calendars didn't operate independently. Instead, they were linked in a complex rotation. Every 52 Hab years or 73 Tzolk'in cycles, the two calendars would end a cycle together and start again from the beginning. This is known as the calendar round, a highly significant period in Mayan life. Meanwhile, the Babylonians based their lunar calendar on the phases of the moon, with 1 month calculated from one new moon to the next, about 29.5 days. A Babylonian lunar year consisted of 12 months, totaling roughly 354 days, shorter than the solar year of 365 days. This led to a discrepancy of about 11 days per year between the lunar calendar and the solar cycle. If you found this video interesting, don't forget to hit like, leave a comment to share your thoughts, and subscribe to the channel so you won't miss out on the next exciting adventures. Let's spread knowledge to even more people. To correct this discrepancy and align their calendar with the seasons, the Babylonians added leap months. As pioneering astronomers, the ancient Babylonians observed celestial cycles and discovered many fascinating phenomena, including notable stars, especially Venus. This discovery not only helped them create an accurate calendar, but also laid the groundwork for astronomical and calendrical knowledge in many other civilizations. The knowledge and achievements of ancient peoples in astronomy were often passed down and used for a long time due to their accuracy in daily life. By the Renaissance, many scholars began to question the true nature of the planets. When observing with the naked eye, we could only distinguish the sun and the moon. The rest of the stars appeared merely as glowing dots in the sky. To gain deeper understanding of the universe, humanity needed a special tool to observe these planets. That tool was the telescope. In 1608, a Dutch lensmaker named Hans Lippershey was the first to file a patent for a device capable of magnifying distant objects. It was compact, handheld, and consisted of a convex lens at the front and a concave lens at the rear. Thanks to this design, users could enlarge the image of faraway objects for easier observation. However, due to its simple construction, the image seen through Lippershey's telescope was inverted. Additionally, the magnification was only around 3x to 4x, not powerful enough for humans to observe planets and stars in the sky. Furthermore, the image quality was not very clear, making it difficult to view celestial bodies in detail. Nevertheless, this marked an important step forward in the development of long-distance observation tools and served as inspiration for scientists to improve telescopes in the pursuit of space exploration. It was during this time that everything began to change. A major turning point occurred in humanity's journey to explore the vast universe. The geocentric model of the cosmos proposed by Ptolemy was no longer accurate. European astronomers began to develop different perspectives about the universe and the planets. Among them was this man, Nicholas Copernicus, one of the most significant figures of the Renaissance. His research not only fundamentally changed humanity's understanding of the cosmos, but also laid the foundation for the scientific revolution, paving the way for the development of modern science. This was the heliocentric theory. Although this theory had been proposed in ancient times, it was not widely supported. However, after years of study, Copernicus agreed with the idea that the Sun is the center of the universe, while the Earth and other planets orbit around it in circular paths. In addition, he introduced several new concepts that were described as being much more accurate and simpler. According to him, the Sun holds the central and fixed position, not orbiting any other celestial body. The phenomenon of day and night is due to Earth's rotation on its axis, not because the entire universe revolves around the Earth. Each planet in the solar system orbits the Sun along its own unique path. Additionally, Copernicus argued that the planets are located at varying distances from the Sun. This helped explain the differences in their apparent speeds of motion. Before Copernicus's time, calculating the positions of planets was extremely complicated and required numerous mathematical operations to explain their movement. With the heliocentric model, the astronomers succeeded in simplifying this arduous task. It laid the groundwork for future scientists and enabled humanity to describe the universe with greater accuracy. His research went beyond the realm of astronomy and sparked a profound intellectual revolution. The heliocentric model challenged the long-held belief that Earth, and by extension, humanity, occupied a central and special position in the universe. This paradigm shift encouraged people to reevaluate their place in the vast cosmos, influencing both philosophy and theology, and challenging the traditional views held by the Catholic Church. Moreover, it helped pave the way for rationalism and the rise of modern science. Many followed in the footsteps of Copernicus, continuing to bring humanity closer to a deeper understanding of the vast universe. They broke away from outdated views of the world and the cosmos, presenting new research that, despite controversy, pushed knowledge forward. After all, and yet it moves. You've probably heard this famous phrase at least once. It was astronomer Galileo Galilei who famously made this statement. He is considered one of the most important figures in the history of astronomy and physics. Galilei was the first to apply experimental methods and scientific research, laying the foundation for modern physics and astronomy. To explore planets and stars, he built an upgraded version of Hans Lippershey's telescope. Galilei's device could magnify objects up to 20 times, enabling him to make several groundbreaking astronomical observations. Most notably, he discovered 4 large moons orbiting Jupiter and found that the surface of the moon was not smooth, but covered with mountains and craters, contrary to the belief that celestial bodies were perfect. If you found this video interesting, don't forget to hit like, leave a comment to share your thoughts, and subscribe to the channel so you won't miss out on the next exciting adventures. Let's spread knowledge to even more people. In addition, Galileo also observed sunspots on the Sun, showing that this massive star undergoes many changes. Notably, his discovery of the phases of Venus marked a major breakthrough for humanity. At the time Galileo lived, the Catholic Church and European society still strongly believed in and adhered to Ptolemy's geocentric model. However, Copernicus later questioned its accuracy and introduced the heliocentric theory, sparking major controversy. Galileo's groundbreaking discovery regarding Venus became one of the most famous stories in space exploration. In 1610, he published The Starry Messenger, a record of his astronomical observations. The work caused a sensation and drew the attention of both the scientific community and the Church. He presented strong evidence in support of the Copernican theory, which the Church viewed as a provocative act of defiance against established doctrine. In 1616, the Church warned Galileo not to teach or advocate for the theory. Nonetheless, Galileo continued his research and even openly debated with scientists and clergy who supported the geocentric system. In 1632, he published Dialogue concerning the two chief world systems, in which he compared Copernicus's heliocentric model with Ptolemy's geocentric one. Although the tone of the book was neutral, its inclination toward the heliocentric theory was quite evident. The book stirred major controversy and provoked the anger of the Church. In 1633, Galileo was summoned by the Inquisition in Rome and faced charges of heresy. At the trial, Galileo was threatened with torture and forced to recant his support for the heliocentric theory. Under immense pressure from the Inquisition, he signed a confession stating that the Copernican theory was erroneous and incompatible with Catholic doctrine. It was at this moment that Galileo is said to have murmured, "And yet, it moves." This famous quote expressed Galileo's firm belief in the scientific truth that the Earth continues to revolve around the Sun, regardless of whether the Church acknowledged it or not. He inspired later scientists, such as Johannes Kepler and Isaac Newton, who continued researching and developing scientific theories about the universe. Galileo's contributions were not limited to astronomy. They also paved the way for the advancement of modern science, helping humanity better understand its place in the vast cosmos. By the 17th and 18th centuries, tools used for studying stars and planets had become much more advanced. Many brilliant scientists began creating their own, more modern telescopes. One of the most notable was this man, Isaac Newton. He's not only famous for the story of the apple falling on his head and discovering gravity, but he was also an inventor of telescopes. In 1668, Newton observed that the telescopes of his time produced blurry and inaccurate images. He sought to improve this functionality by studying and replacing the lenses. The scientist used a parabolic mirror as the main reflective surface instead of a lens. Newton used a concave mirror to gather light from celestial bodies through an aperture and focus it onto a point inside the telescope. The device also included a flat mirror placed at a 45-degree angle near the focus to reflect the light sideways, where the observer would look through the eyepiece. Finally, the eyepiece's main function was to magnify the image for better viewing. Newton's reflecting telescope made observations much sharper and free of color distortion, allowing scientists to study planets more easily. Additionally, the cost of production was lower since mirrors were easier to make and did not require the high purity levels of large lenses. Newton's invention marked the beginning of the era of reflecting telescopes, which would go on to become the standard in modern astronomy. Thanks to it, astronomy turned to a new page with deeper exploration into space and the stars. Alongside the development of telescopes, by the end of the 19th century, scientists also began to study and understand more about the lifespan and evolution of stars. This was considered a significant breakthrough, adding new pieces to the grand puzzle of the universe. It was two scientists, Hermann von Helmholtz and Lord Kelvin, who helped humanity reach that understanding. They discovered that stars begin to form within massive clouds of gas and dust known as nebulae. Under the influence of gravity, regions within these gas clouds start to collapse and gradually form a dense mass, generating extremely high temperature and pressure at the center, eventually forming a star. When the temperature and pressure at the core become high enough, nuclear fusion reactions begin, in which hydrogen is converted into helium, releasing energy in the form of light and heat, causing the star to shine and officially become a star. In addition, humans also learned more about the Milky Way, the home of Earth and hundreds of billions of other stars. The great astronomer William Herschel was the first to make detailed observations of this large spiral galaxy. He used his giant telescope to map the distribution of stars in the Milky Way and recognized its shape. He also observed that the Milky Way was not a dense cloud of stars, but contained a vast number of scattered stars. By the end of the 19th and the beginning of the 20th century, astronomers began to realize that the Milky Way was just one among millions of galaxies in the universe. These discoveries became clearer thanks to advancements in telescopes and spectroscopy, which helped scientists classify galaxies and better understand their formation and structure. During this period, Edwin Hubble discovered that the Milky Way was not the only universe. By observing nebulae, Hubble demonstrated that these nebulae were in fact separate galaxies. These critical findings allowed humanity to gain deeper insight into space and recognize our own smallness within the vast universe. Shortly after, in the 20th century, humankind made a series of major advancements, taking its first steps in conquering space. One of the most important scientific breakthroughs of the 20th century was Albert Einstein's general theory of relativity, published in 1915. This theory changed how we perceive space and time. Instead of viewing them as separate entities, Einstein described them as a unified whole called space-time. If you found this video interesting, don't forget to hit like, leave a comment to share your thoughts, and subscribe to the channel so you won't miss out on the next exciting adventures. Let's spread knowledge to even more people. With the general theory of relativity, Einstein introduced a cosmological model in which the universe is not static, but can expand or contract. This opened up new questions in the study of the universe's origin and structure. In 1920, astronomer Edwin Hubble discovered that galaxies were moving away from each other. This proved that the universe is expanding and increasing in size. This groundbreaking finding led to the development of the Big Bang model, a theory that suggests the universe began from an extremely hot and dense point about 13.8 billion years ago. After a massive explosion, the universe came into existence and has been expanding ever since. And yet, humanity's understanding of outer space continued to grow. During this period, numerous achievements marked mankind's journey into the cosmos. At exactly 22:28:34 on October 4th, 1957, the R-7 launch vehicle was activated at the Baikonur launch site in Kazakhstan, carrying the Sputnik 1 satellite, a shiny aluminum sphere, into space. This marked the first time a human-made satellite entered space. 34.5 seconds after separating from the rocket, the satellite began transmitting beep-beep signals that could be heard from ground tracking stations on Earth. Sputnik 1 entered orbit at an altitude of 947 kilometers, carrying with it humanity's aspiration to conquer space. The aluminum sphere, measuring 58 centimeters in diameter and weighing 83 kilograms, orbited the Earth 1,440 times, covering a total distance of 60 million kilometers over 92 days. This marked the beginning of the space age for mankind. Just 4 years after Sputnik 1 entered space, the Vostok spacecraft carrying cosmonaut Yuri Gagarin launched from the Baikonur Cosmodrome in Kazakhstan. 10 minutes later, the spacecraft entered orbit at a speed of 29,000 kilometers per hour and reached a maximum altitude of 327 kilometers. Gagarin became the first person to see our shared home from outer space. After completing his orbit of Earth in 108 minutes, he and his re-entry capsule safely parachuted to a field in Saratov, Russia. This first human spaceflight was a monumental success, an immense source of pride, and one of the Soviet Union's greatest achievements during the Cold War era. And the Soviet Union's space rival, the United States, was not about to fall behind in the race. The Americans responded swiftly with a bolder, more challenging plan: to become the first nation to conquer the moon. On July 16, 1969, the Saturn V rocket launched the Apollo 11 spacecraft, carrying 3 American astronauts: Neil Armstrong, Michael Collins, and Buzz Aldrin. After more than 3 days orbiting in space, on July 20, 1969, Apollo 11 officially became the first spacecraft to bring humans to the moon. Armstrong was the first person to set foot on the moon's surface. That's one small step for a man, one giant leap for mankind. This monumental achievement did not mark the end of humanity's journey to conquer space. On August 10, 1975, NASA officially launched the Viking program. The 2 spacecraft, Viking 1 and Viking 2, were tasked with landing on the red planet, Mars. This became one of the most expensive yet highly successful missions ever undertaken by NASA. The Viking missions collected a wealth of important data about Mars, significantly aiding research on the planet considered most similar to Earth within the solar system. Notably, the data revealed traces of massive water flows that once carved valleys and deep channels into the Martian surface. To support the process of space research and exploration, astronomical equipment was also greatly upgraded and enhanced. One of the most significant breakthroughs of the 20th century was the Hubble Space Telescope. Launched in 1990, Hubble revolutionized our way of observing the universe. By observing celestial bodies without interference from Earth's atmosphere, Hubble delivered sharp, detailed images of galaxies, stars, planets, and various astronomical phenomena. The Space Telescope helped confirm many cosmological theories and provided compelling evidence of the universe's expansion. In addition, the development of radio telescopes opened up an entirely new era for astronomy. If you found this video interesting, don't forget to hit like, leave a comment to share your thoughts, and subscribe to the channel so you won't miss out on the next exciting adventures. Let's spread knowledge to even more people. Humans have gained further understanding of phenomena such as supernova explosions, quasars, and pulsars. Many experts realize that our knowledge of the universe is still extremely limited. Therefore, nations must cooperate to expand our understanding and lay the foundation for long-term missions in the future. From this need, the International Space Station ISS was born. It is a shared home for astronauts and space scientists from various countries, including Russia, the United States, Japan, and Canada. Together, they conduct research in various fields, such as the microgravity environment, space exploration technologies, and astrobiology. The ISS is not only a technological marvel and symbol of international cooperation, but also a crucial step laying the groundwork for humanity's future ambitions. With the help of spacecraft and satellites, humans have rapidly expanded their understanding of the planets in the solar system. This also marked the beginning of humanity's journey to explore the outer edges of the solar system. On January 19, 2006, the New Horizons spacecraft was launched into space with the mission of exploring Pluto. It was launched at a very high initial velocity and later used Jupiter's gravity to accelerate even further. This method is known as gravitational assist. In 2007, the New Horizons spacecraft approached Jupiter, collecting valuable image data of the planet and its moons. At the same time, it used Jupiter's gravity to accelerate and continue its journey toward Pluto. Taking advantage of the encounter, New Horizons captured photos and conducted scientific observations of Jupiter and its satellite system. After receiving the gravitational boost, the spacecraft continued its multi-year voyage into deep space. On July 14, 2015, New Horizons reached its closest approach to Pluto at a distance of approximately 12,500 kilometers. This marked the first time humanity had ever seen this dwarf planet up close. After completing its Pluto exploration mission, NASA extended New Horizons' mission to study the Kuiper Belt, a region beyond the solar system filled with icy bodies and believed to be the birthplace of comets. By 2019, the spacecraft had approached the object known as 2014 MU-69, later named Arrokoth, setting a record as the most distant object ever explored by a spacecraft. To this day, humanity has made remarkable strides in the exploration and understanding of outer space. Many missions have been launched, and great successes have been achieved. Yet the quest to explore space now stands on the brink of a powerful new era, one filled with ambitious plans, from landing on Mars to observing exoplanets outside the solar system. Humanity is getting closer to a deeper understanding of the universe and our place within it. These plans once seemed vague and unachievable, but you and I have witnessed them gradually come to life. Without a doubt, the coming decades promise to be a golden age of space exploration, marked by daring missions, advanced technologies, and discoveries that could completely transform how we perceive the cosmos. From early skyward observations of stars to modern achievements in space, humanity has gradually conquered the vastness of the universe. The accomplishments we have made are the clearest testament to the brilliance and boundless curiosity of the human spirit. Every era in history, with or without modern tools, has contributed valuable knowledge to the vast cosmic picture we now understand. With planetary exploration missions and space telescopes, we are closer than ever to uncovering the origins of the universe and the potential for life on Earth. This journey will no doubt face many difficulties and challenges, but it has never stopped humanity from continuing to explore, now or in the future. The human quest to conquer space will not come to an end, for there are still countless mysteries we have yet to uncover. With the continuous advancement of science and technology, future generations will surely carry on this grand journey, expanding our vision into new realms of the vast universe. If you found this video interesting, don't forget to hit like, leave a comment to share your thoughts, and subscribe to the channel so you won't miss out on the next exciting adventures. Let's spread knowledge to even more people.